Let's have a look at what we've got here. 2 chunks of steel. You saw how 1 chunk became 2 chunks. So, right here is the pattern on this face. And you can see how it's being dragged down into the center in a matching way. That's good. You can see where the pieces, the final like stack of welds, seams are. Boom, 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 boom. And then, so we've ground the inside faces clean. I dug just a slight bit after a couple of pits that needed more. But other than that, that's surface ground. That's gonna weld nice. And then we just kind of skimmed off all around, didn't take much. Just the areas where there's gonna be a MIG bead, because I am going to dry weld this, which means just MIG bead all the way around the outside. As opposed to TIG. TIG would work too, but MIG's a little bit stronger since it has some added mild material. Helps the weld not crack out. And I grind the dome off anyway, so it's a comparable amount of foreign material added to the billet anyway, which is negligible. So anyway, ground bright all the way around so we don't get oxidized welds from scale. So we're going to do that. And then I'm going to not weld a handle to it yet, because I want to be able to like handle it with tongs under the hammer a little bit. What I got to do is shrink it in this direction a little bit. Right now it's about 4 inches that way. I need to shrink it down to about 3 for 3 1-inch slices for integrals. I need to stretch it a little bit this direction, and I need to knock it down a little bit in size that way to probably 2.5 inches from like the 3 that it's at now. So shorter, longer, narrower. And then when it gets to that point, by golly, I am going to have a loaf to saw some blade blanks off of. Anyway, let's MIG this up. Okay, I lied. I welded a handle on it after all. So you can see now the pattern is in this face and in this opposite face of the bar, with the snout of the pattern, i.e. what's going to become the tips of them, up here, and then the tang end of them right here. So really what I got to do is just draw this out. I got to weld it a little first, make sure it's stuck, then age it really to improve the bond. Then I'm going to draw it out that way, like this on the dies, flip it, draw it out that way a little bit less, preserve a little bit of this height, knock some of this height down, and then just stretch this till, you know, maybe it's 4.5, 5 inches long by 3 inches thick, and then I'll be able to saw slices off the loaf. So firing up the forge, and the next thing is going to be the last of the forge welding for this steel. There will be some more forging after that, but it'll just be actually forging integral blade shapes out of the finished Damascus. Quick note here, I'm putting some 30 weight non-detergent oil from the big oil can into the oil points on the hammer here. Always got to remember to do this stuff. If you have a power hammer, you'll already know this, but I'm here to remind you. On a Bodger, you put it on the rollers there and on the ram guides. I thought while I was waiting on that heat, I'd take you guys on a quick visual tour of the shop. We just passed the Marvel bandsaw. We're going around in through the other roll-up door. Here's my 28-inch Ohio heavy shaper. We're coming in past the bandsaw there on the left, and then the cutting torch there, heating torch past the PID forge. Here's my 250-pound Miles Bement utility hammer, designed for steam, run on air. We're looking up at some of the control wiring for the Baudry. There's the 300-pound Baudry. Coming over here into the second forging station, 142-pound Trenton rolling mill, 25-pound forging press. Built that one myself. A little punch press I'm working on. My big lathe. That's the Pratt Whitney Model C. Here is my 5 horsepower Brilliant cutoff saw. Brilliant, that is. Dust collection system for the surface grinder and chop saw mainly. Going through the grinding area right now. There's my abrasive 3V surface grinder on the left. Back to my welding station. Another look at the surface grinder there from the operations side. Coming into the small room now. Looking down the machine alley at the die filer, pantograph there. There's my big dual bandsaw, model V36. And here is my Index Model 645 knee mill. I need to put a little work into restoring that thing. It works, but it needs stuff. Back past the plasma cutter here, and onto the hammer. When we get done with this welding and drawing sequence, we'll have not only stuck it together, but we'll have drawn it out a little bit and gotten it to the right final dimension to saw into slices from the loaf here to forge blades out of. We don't want it anything under 3/4 thick per slice, and a little heavier would be nice. And here I'm getting pretty close to final dimension, and you'll see I'm going to let the billet cool quite a bit more this time. This right here is the last end of the last heat on this before it's getting forged into blades. So I need to be nice and square without any bulges on the sides. I need to be to my dimension, and I want to have nice sharp corners to reduce grinding waste and make it sit right in the saw vise and everything like that. And with that, the last forge weld on this entire billet is done. We have quite a good amount of material. Nothing like what we started with, of course, but not 50% loss, maybe 30-40% loss, which over the course of 5 days or so of working on this thing is not bad. And we got some good dimensions here. So the big flat side here is actually the non-grain side. All the pattern is in here. So when we cut cookies, they'll be going off like that. So we're about 2.5 to 2 3/4 inches here. So we'll be able to cut at least 3/4 inch thick slabs off of there, and then have room for a saw blade and a little grinding. So that's perfect. starting stock size material to forge integral chef knives out of. This is like about 2 inches tall, and we're 5.5 inches long there, so it's going good so far. We'll just let this cool down slowly, and then we'll throw it up on the Marvel saw and cut some slices.
You can see how handy this saw is for this type of ripping cut. I've marked the billet out carefully, and I'm using these toe clamps here, milling style clamps, on a base plate that I've made that fits in the hydraulic clamp on the saw bed.
Well, here's one off the saw. There you can see the side grain as a feather a little bit still there. But boy, inside, beautiful, clean steel. Really nice bandsaw cut too. So this is going to be an integral chef. And then I got the other cut happening right now, and that's going to be 2 integral chefs when that one's in 2 pieces. Well, here we are, guys. I just had to check etch it, because you always get that little paranoid voice in the back of your head. Did you feather cut it the wrong way? Well, I was pretty darn sure I hadn't, but still, would if I had. Anyway, look at those little links in there. They're quite compressed now, but they'll be drawn out to where the links are wider and bolder by the time this is forged into a knife. But I couldn't be happier with how the feather cut, reassembly, everything went. Orientation looks clean, links are distinct. And I'm breathing a sigh of relief for this one. And next we'll start with forging a couple of these pucks into blades.
So I've just got another one of these handles with a bent tail, piece of rebar with a directional tail on it. I'm going to weld it nice and stout on there. Well, we're going to do some forging to shape here. Now I'm using a 1/2 inch step down pallet. Just a mild steel tool on a little 1/4 inch stick handle for less vibration to the hand. And I'm starting to step down for the bolster here, upsetting the bolster a bit to create where the heel will be. Now I've gone to a 3/4 inch stick block. I'm doing the same thing. You could also do this with a wedge style tool to isolate the bolster. I like using these increasingly thicker step blocks because it allows me to keep my spine clean and straight a lot easier. Here we're going to the 1 inch pallet step block tool, and you can see I keep truing up the side every now and then. And I'll drive this tool down until it's pretty much bottomed out, and then I am able to once again straighten the blade and bolster to each other. Here we're going to a guillotine fullering tool mounted in the anvil hardy. Made this tool myself. It's just basically made out of a base plate with angle iron guides. I'm going at a little bit of a forward angle with this, right at the front of the heel feature that I knocked in. And I'm not trying to drive a deep dent. It's basically just a little mark to kind of start where the bolster will be. A visual demarcation and kind of a little guide for the fullers to ride on as I'm pulling the heel width out. Here is a lower die saddle with a tooling socket, and that is holding my width fullering tool. It's just got a long spring holding the 2 half-round dies in alignment, and I am pulling the heel width out somewhat right in front of the bolster. I like doing this early in the game when I still have plenty of mass in the blade, so I can go ahead and be proactive in locating that mass out toward the heel where I want it to be. You want to have a nice tall heel on a full-size chef knife, and I like that to end in a nice crisp heel, like right at the bolster front, so it doesn't look like concessions were made to lack of forging skill during the process. And every now and then I'll just come along with the 1-inch pallet tool and keep everything straight in between there. You got to be proactive in not letting problems get away from you as they develop. And here I'm actually beginning the process of drawing out some blade length. Now that I have my heel width out to a good starting width, I need to go ahead and get some of that excess mass out of the way by pulling it out toward the tip. And now we're doing some more drawing, obviously, just bit by bit using the leading edge of the die to do the drawing. That's the way to do it with flat dies. And now we have gotten to the point where we've graduated to using the 1.5-inch step block, because the heel is wider than an inch taller than the bolster, so the inch depth block is now too short. Here I'm using a crowned light width drawing tool. It's basically a mellow top fuller, and I'm using that to begin just gradually blocking out the taper out to the tip. And you can do this stuff with a hand hammer, of course. The only thing is the billet is still, you know, between 3/8 and a 1/2 inch thick here, so it just helps to kind of get the power of the power hammer into it right now. Same process, just doing it from the top side this time. Trying not to make any deep dents, but trying to overlap the tool a lot so I don't get any weird bumps in the pattern. Now we're starting some of the hand forging. Now that the billet thickness has gotten a little bit less, I've done a little bit of the heavy taper drawing work on the hammer. I'm using a 6.5 pound dog head hammer made by Ilya. This is a very nice hammer, perfect for this kind of work. You don't want to hammer fast with it, just accurate and hard. And it has the authority to really kind of like continue knocking this tip shape in, even with that blade at 3/8 of an inch thick. And here's something that I frequently do. If I want to make a 10-inch chef, I'll use a ruler and a Sharpie or soapstone and mark 10 inches from the front of the anvil face back into the body somewhere, and then a 2 1/4 inch width for this knife there on the front step, so I just have some visual cues to forge to. And we'll go at it a little bit more with the big dog head hammer. Well, Japanese cutler's hammer, a little different from a dog head. The handle angle gives a little bit of a forward curve to it, which is a nice feel for it. Helps you control. And of course here just a little bit more flattening and drawing, truing up of the mushrooming that the hand hammer put into the edge. Now we're going to a 4-pound combination hammer by Steve Howell of Ballard Forge in Seattle. This has a wider face and a flatter face, and this is a very good hammer once the steel gets a little thinner for just adjusting and kind of truing everything up along the profile to everything else and taking any hammer dents out of the profile. Okay, now that I've got the basic profile forged in, I've switched to a 3.5-pound crossbeam hammer. It's just an old industrial hammer I picked up at secondhand somewhere, and it just has the perfect kind of weight and like handle shape to it right now for this. I'm pulling the heel back toward the bolster, well, back toward the handle area, just to kind of get it into a more of a crisp point there. Flip it, do it from both sides. Now I'm pushing it out before I was pulling it. I like to do it on kind of the corner of the anvil face there. Gives me a nice spot to isolate that heel. And I like to do this while I still have, you know, maybe 5/16 of an inch thickness there at the edge, so I have just plenty of material to pull that heel back to the exact kind of shape that I want without running out of material. And sometimes I'll do this in the post vise, sometimes I like to do it at the anvil, just kind of bumping that heel square from the back side there, and then between bumping it from the back, hitting it from the top, drawing it out from the side, you can get that heel out to a nice crisp point that you really don't have to grind a lot off to get whatever shape you might want. Here's a little trick that you might find handy. So it's very common to develop an unfortunate sort of little hump in front of the bolster on the spine of the knife there. You can put you a little block on the anvil, like I did, whoopsie, and set the bolster on it, and then you can just forge that hump down while you're supported on the bolster pretty easy, just to get rid of it, no problem. Quick side note here, I'm using a Jacob Ferrum forged combination hammer, 3.5-pound. This is also a very nice hammer with good clean faces. The forging on it is just gorgeous. So with the blade shape mostly taken care of, now we're using the guillotine again to kind of mark where the back of the bolster is going to be. I'm going to hit it a little harder this time and do some of the work really of really putting in an indent and starting the shape of the tang there. I'm going to definitely leave some for the hammer to do, leave some thickness there. Take a couple of heats at it to where maybe the web is going to be about 5/16 at the bottom of the blows there, which gives me a pretty good shoulder to run the hammer up to as I'm drawing the tang down. Now we're going for it on the edge of the flat dies with the bowdry, and I try to just always watch exactly where I'm located on the die, and also in relation to where the top die is coming down, so I don't screw up and like nip my bolster. This hammer's got pretty good die alignment and not a lot of slop, but it's still a little bit possible. This is another instance where it's very important to be conscious of the angle that you're holding the work at. I'm kind of floating the tip up in alignment with the surface of the lower die. That way it's not bending my tang back and forth as I'm flipping the knife around to get it from each side. And you want to do this pretty hot too. The worst thing is if you're doing it too cold and you're bending your tang around too much by holding your work wrong, it can stress crack it and possibly break it off or make it unfixable. And you can get it pretty good on the hammer, but you can only ever get it so good. And here at the end on this last heat, I really like to sight down the knife from each side, spine, edge, side, and do a little bit of corrective straightening. Keep sighting down, see what your straightening did. You need to make sure that the end of the tang isn't dropped in relation to where it needs to be with the blade. You need to make sure it's not bent to either side. And if it's off center with the bolster and out of line with the blade, you got to correct that at this point here. I'm pretty careful to not have that happen when I'm at the hammer. Flip the knife around and do some of the work from each side so it doesn't end up too offset. But you can, if you do develop some kind of off-kilter lines through the bolster from blade to tang, you can fix a lot of it here with a hand hammer at the end.
Alrighty guys, in here I've got 2 blades forged out of this. One was an order, one might be spoken for. Actually, the third one's spoken for too, but they're just kind of different orders. Anyway, these are going in the Paragon. We're shutting the door. And I already rough normalized them a couple times out of the forge. And then right before we quench, we'll normalize them too. So I'm not going to write a normalize into this series of cycles. We're just going to do a DET anneal right now. So let's go with program. User 7, as I recall. Full ramp to 1365. Hold it for half an hour. Cool. 670 per hour down to 1200. Nothing after that. And yep, that's our DET anneal. It's going to set us up nice for grinding. It's going to set us up nice for heat treat, really. So we're just going to set it and forget it, and we'll be back to take these out later.
Here's how I hold them on the surface grinder at an angle on the chuck with the bolster hanging off. And I'm just taking the thickness down to about 120 thou flat all over before heat treat. There's a little wedge of blade unground right in front of the bolster. You can see there a triangle wedge. And every time I flip the knife, I just freehand grind that little bit of material the surface grinder can't get to.
Okay, here's where we are with the 2 blades that we forged out yesterday. These are both big guys, 10.5, 11 inches. So got forged integral bolster. You can see the pattern flow down from the bolster. It's very nice. We got this thing where a couple of the links are tangled up. Interesting how that happens. But overall, it doesn't look too bad. Nice pattern flow. All the way out to the tip where the links get pretty wild and distorted because I forged that tip heavily in. And that is a choice. You know, you could choose to just not forge the tip in and then cut it in and have less distorted links out there, but I like how that looks. So there's that. There's one of them. Surface ground to 120 thou. And everything just blocked out, the tang and stuff, just to get it dimensional enough to heat treat well and not warp due to uneven mass. Same deal here. Forged in the tip. And good pattern in there, so just got this big old pair of feathers. We're gonna go stick them in the oven and get a nice hardness on them with that brand new Parks 50.
I'll walk you through the quench here a little bit. So duck them right in the oil out of the oven. I do keep the door closed. I'm going to interrupt this quench after about 10 seconds. Pull it out. Still a little too smoky. Put it back in for a couple seconds. We'll pull it out again when it's slightly less smoky. I know I got a good quench on the blade. Now the bolster is still a little bit thicker than the blade, of course, and so there's some residual heat in there. I don't want messing things up. I flip it over, duck just the bolster for a few more seconds. Now that everything is quenched sufficiently, I don't have a bunch of heat hiding out in that bolster that's going to over-temper the heel of my blade or anything. I am going to cool it off in the not cool it off, wipe it off in the gross rag. Just get the scale off, have a look at the blade real quick. And once I've mopped it off, I'll be able to hold it up and kind of sight along it here and evaluate, did it warp? I have my heavy welding gloves on here so I can grab it. It's still at like 500-600 degrees. So I can grab it and just bend it by hand strength. It's still real soft. It hasn't hardened yet. And I can kind of tweak it anywhere I might need to get it roughly straight before I let it cool down the rest of the way at room temperature. That's what you call a mark winch. Here I'm doing the second one at super speed. See it all again, flip it, grab the bolster, mop it off, and hold it up, sight down it, find any kinks in the blade, or if the tang is bent in relation to the blade, anything like that, and quickly try to straighten them, and then set them aside to cool. As soon as they cool down enough to room temperature, I'll put them right into temper. So I'm going to go throw these into a 300-degree snap temper in the house while I'm dumping heat out the Paragon. Thanks for watching this far, and then stay with me for the next installment.